Thank you, Dan from D'Agostino Audio. Thank you for this interview today. We're here at the Australian Hi-Fi Show, and I wanted to ask you, firstly, I wanted to actually congratulate you on the new momentum amplifiers that have grabbed headlines all over the world and have excited a lot of people. And they certainly look totally different to anything else that's around. And my first question, I guess, is they're a departure from anything that you've ever done before in terms of Krell. What makes the D'Agostino amplifier different?
Well, the D'Agostino amplifier is designed along the roots of been 30 years of my work, and the D'Agostino amplifier was a combination of all of the things that I've learned and I wanted to do. And I kind of put them all into one thing. You know, it's been a labor of love because I love music, and I wanted to make something that just played music and did it in an exemplary way. And on the side, it needed to look beautiful.
Sure. Now, can you just briefly outline some of the technologies that are involved with the new amplifiers? If there's anything that's unusual from what you've done in the past?
Well, they're very low feedback designs. They're very low gain designs. It's a very low gain amplifier. It uses some very unique principles in the gain stages. It of course uses copper as a heatsink, which is an extremely good heatsink for audio use. You know, the copper heats up and stays at a temperature which holds the whole all the output devices at the same temperature, and allows them to operate in an ideal mode. Well, it's all bipolar, and it's all through-hole design. I moved completely away from using any surface mount devices, and also the amplifier uses no digital parts in it. It's all analog. All of the protection circuits and anything that's in there is done in the analog domain that pertains to any auxiliary function other than sound. So the whole amplifier is pure analog. As I said, we moved away from surface mount, so everything's through-hole, and that means that we hand solder, we hand test it, we pick and categorize and curve trace all the devices in the amplifier so they're perfect, and each one mimics the one before it. So that's a very important thing to us, to be able to make and completely control the processes that are inside the amplifier. The copper is a wonderful part of it because it allows us to have a totally different type of heatsink that treats the output device differently than an aluminum heatsink, which the copper keeps the output temperature of the device relatively constant and relatively low.
But is there a reason why other manufacturers don't use copper in their heat sinking?
I don't know. I couldn't answer that question. I really couldn't.
Sure.
I certainly have always wanted to do it, and then I thought about it, and it really does work well for a heatsink. It's extremely good, and imparts a whole bunch of different pluses to the amplifier design.
Sure. Now, what do you consider the crucial elements of amplifier design in general, and then also apply that to the new amplifiers?
Well, I think that linear distortion and linear gain are very, very important. You know, our distortion at 20 hertz and 20K are almost identical, which is unusual for an amplifier. Also, you know, feedback is a good thing as long as it's not overused, and I think that I've not used too much of it. I have around 6 dBs of feedback in the amplifier, and it's not global. It's nested between the drivers and the input. So those are some of the things I think an amplifier has to have. Plus, it has to be able to drive, you know, all sorts of difficult loads. So it needs a big output stage and a big power supply in order to do that.
Sure. How were you able to condense the size of the power supply to fit into such a small chassis?
Well, I'm fortunate that I have a transformer manufacturer about 20 miles away from me, and he and I work very closely together with the size and cavity in the unit that I had to work with, and we did a lot of work together and finally came up with a 1.4 kilowatt transformer that does what we needed to do.
Okay. And the capacitor bank, you're using larger capacitor sizes?
Yeah, the capacitor size is it's roughly 90-some thousand microfarads in there.
Sure. Okay. Now, in light of some of the recent improvements in Class D technology in terms both of sound and the technology itself, is that something that you would consider using in upcoming products?
No, I don't plan on making any computer speakers or portable devices. So I really would have no use for Class D.
Sure. Okay. And you don't see Class D fitting into the high-end audio in any way?
I mean, maybe it will someday. It may someday fit in. At this point, for me, it's not in the cards. I mean, maybe some other people have different thoughts on it, but I've never gotten really good audio results with it.
Sure. Okay. Now, we hear there's a matching preamplifier coming soon. What are some of the interesting technical aspects of the new preamplifier?
Well, it's got a very unique volume control. The volume control uses two different devices to achieve a level. It uses a multiplying DAC to actually select the level, and then it uses an R-to-R network that inserts a resistor in front of the multiplying DAC. So once the multiplying DAC reaches the required volume level, the relays, which is the R-to-R network, eliminate the multiplying DAC, and what you're listening to is just a pure resistor in series with your signal.
Okay. There's been a lot of buzz, I suppose, on the internet on LDRs and light-emitting volume controls, or light-controlled volume controls. Have you ever? Did you consider that at all?
No, I didn't. I never considered that, because what I really wanted to do was to have a pure R-to-R network, and I know that there's nothing. I mean, a really high-quality resistor like a CADOC or a Dale or a number of different very high-quality resistors sound better than anything you can put in series with your audio signal or any pod.
Sure. Now, how soon will the stereo amplifier, how will that differ? The upcoming stereo version of the monoblocks, how will that differ to the monoblocks?
Well, it's going to look exactly the same. It's actually made in the same chassis. Uses 2 meters in the front. Of course, it'll have 2 outputs and 2 inputs on the back. But it's a 200 watt amplifier with a similar size supply, but we're driving 2 channels, and so it won't be able to put quite as much power into any speaker load as the mono amps. But the nice feature on the stereo amp is that if you buy it as a building block, you can send it to us and we can convert it as a mono for you, and you can buy another mono and move up to a mono at any time you want.
Sure, okay. Now, obviously, the distinctive feature is the meter. Is there an interesting story briefly behind the meter and why you chose to use one?
Well, I wanted to attract attention to people who are collectors, watch owners, and people who like really exotic-looking things. And I thought the movement, in the meter movement with a hand that's styled after a Breguet watch, was an important thing to put on there, like it's a catch. And the fact that the meter has a lot of little fasteners around the outside, like many watches that are built today, and then the quality of fit and finish on the unit is much like a very expensive watch. So I just wanted to draw the attention, and I like meters, and I think a lot of people like to see them.